Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode problem 2570. Merge two 2D arrays by summing values. You are given two 2D integer arrays nums1 and nums2. So this nums1 and nums2 will contain a pair of values which are first is id and another one is value. And id are unique elements, whereas value may be repeated two or more times. Now we want to return a result in which the result should be sorted in ascending order by id and the array also given in a ascending order by id, right? See here, sorted in ascending order by id. Now the output should also contain ascending order by id. Inside that we want to do some stuff. What are the stuff? While merging this two array, if two IDs occurs in the two individual arrays, okay, inside one array the ID should be always unique. Inside another array the ID should be unique, but still here also ID number 1 and here also ID number 2, ID number 1 occurs. Then we want to add the values of those and append to the result, right? That's what they are saying in this condition. Now check this example: 1 2 2 3 4 5 1 4 3 2 4 1. Now 1 is occurred here and 1 is also occurred in nums2. Just sum it up. So 4 plus 2 is 6. Now 2 is occurred in nums1, but there is no 2 in nums2. So just put as it is. 3 is in nums2 but not in nums1. So just update it. Now 4 is in nums1 and also in nums2. So just update as sum 6, right? And also we want to output in a sorted order. How to do this problem? First of all, just assume we can use, take this combo, take this element, it is 1, check whether this 1 is in this array number 2. Okay, fine. If this 1 is in this array number 2, then sum it up and return the result, append the result, right? And then take the next element, it is 2, then check whether 2 is in the nums2. If this 2 is in the nums2, fine, just update in the result. Now check whether this 4 is in nums2. If there, just add and update in the result. Here 2 is not in the nums2, so we don't add, just update in the result. Now here this 4 is in nums2, so we add this 1 and this 5, and inside my result I will update as 6, right? This is my approach. Now again we want to traverse to this also and check whether a element that is in this nums2 and not in nums1 and update in my result. Now after this all, I want to solve the result, right? First of all, my result. Now checking for 1. There's any 1? Yes, here is 1. So here's 4, here's 2. So update is 1, 6. Right? Next 2. Whether he has any ID 2? No. Just update 2. Now 4. Any ID here is 4? Yes, here. 1 plus 5, it is 6. Right? Now traversing through this nums1 is completed. Now traverse to nums2. Whether this 1 is in this nums1, yes. Then don't take it because we already taken it, right? Now whether this 3 is in nums1, no, then take it. Now whether this 4 is in nums1, yes, don't take it. Now sort it up, sort this. So after sorting, the result will be like this, right? Now this is the brute force approach. Talking about the time complexity. What is the time complexity of this solution and space complexity of this solution? So time complexity is, just see here this length, this whole length, take as n, and this whole length, take it as m. Now I'm just iterating through m in single m, in entire array m, right? Into, sorry, plus we are sorting the result at the end. We are sorting the result at the end. Maybe in a worst case, it may be length of n plus m. So n plus m into log of maybe n plus m, right? So this is my time complexity, right? Correct. According to space complexity, for sorting in inbuilt function, it uses the merge sort. Right? Inside this merge sort, it uses the space as n. So n plus m, right? So this is the space complexity. So this is for the brute force solution. Now, can we optimize it? So how can we optimize it? Check out the constraint. See this. They have given the ID is from 1 to 1000 and value is also from 1 to 1000. So can we use any data structures apart from this constraint? Can we use any data structure apart from this constraint? If we know about the hash map, I can hash this one first, and 2 and 4. Now after this, I can go along this, then find if 1 is already in hash map, just update by summing it. Else update in the hash map, right? This is my normal approach. But seeing that constraint can make me a inductive solution, right? See here, the solution is, they have given that it is from 1 to 1000. So instead of using hash map, I can use an array of length 1001. Yes, right? Because the array always starts from 0 and the end index will be 1000. I can store directly the value and ID in this. The ID represents this index, and the value represents inside the index value, right? So this is my intuition. Now take for example that same example. Let us take that example. Wait, yes, it is 1 2 2 3 4 5 and another is 1 4 3 2 and 4 1. So these are my two arrays. Now as I told you, we can also take 1001, but still to clearly understand, I take max of ID. We can also take max of ID, right? There is no elements can be assigned further greater to the max ID, right? So I can take an array of max ID 0 1 2 3 and 4, right? Array of max ID is 4. There is no ID greater than 4, right? Now first of all, traversing through one by one in this nums1. So it is 1 inside this one. First initially update everything as 0. Initially assign everything as 0. Now 1 inside this 1, add 2. Now 2 inside this 2, add 3. 2 inside this, add 3. Now 4 inside 4, add 5. Now finished. First nums1 finished. Now nums2 array 1 inside 1, add 4. So it is 6. Inside 3, add 2. So it is 2. Inside 4, add 1. 6. So my array is 0 6 3 2 6. Now just update first of all my index number and the value. But if you want to put 0 0, no, right? The only elements which we have to put inside the result should be the element which don't have the value of 0, right? What is mean by the value is not equal to 0? It means the element, the id occurred in either nums1 or nums2, right? So see here, see carefully. First of all, 1 6, then 2 3, then 3 2, then 4 6. So this is my result. Is it sorted in sorted? Yes, it is sorted. Why? Because index is always in sorted order, 0 to n, right? So this is the solution I prefer. So talking about a time and space complexity. What is the time complexity and space complexity? Time complexity is O of I am traversing through n times and traversing through m times. So O of n plus m. And space complexity is I'm just putting a result variable here, result, which we don't consider because it is a result. We don't consider the resultant array, right? We don't consider the resultant array. So we neglect it and we just consider this array. This array can be max up to 1000 size. So it can be varied from 1001. If we define first I have told you, right? Here we want to define up to 1001. So 1001. It can be nearest constant space. It may be nearest constant space. Still it takes some a little amount of space, right? So this is my second approach. Can we still eliminate the space complexity? Yes. Always remember, as we learned already, if there's a 2 array and we want to maintain in a sorted order, or we want to check for the equality, we can use two-pointer approach, right? So now just take for example that same example, right? It is 1 2 2 3 4 5. This is a first array, and another array is 1 4 3 2 4 1, right? Now check here. Here's my one pointer, here's my another pointer, here is my result. Whether this one and this one are same, yes, then update 1 comma sum this 6. Now update each pointer by 1. Now this 2 and this 3 are same, no, then which value should be taken at first? 2 is taken at first because we want to maintain sorted order. So take this 2 comma 3, update the pointer to 1. Whether this 4 and this 3 are same, no, then update this 3 because it is a smaller value than 4. Now this 4, just update. Now this 4 and this 4 are same, yes, then update by summing it, right? This is my result, right? Now talking about the time and space complexity. What is the time complexity? It is n plus m. What is space complexity? It is O of 1, constant, because this result is a resultant array. We don't consider it as a space complexity. Why? Because it is n plus m as time complexity, because we are iterating n times and we are iterating m times this array. This m, this n. So let us check for the code part. See here, this is a better approach. I have declared all values inside that 0 into 11101, which is a max value that we can achieve for a comma b in nums1. So I am just unpacking those and storing a as id and b as value. Now all values of id plus is equal to val. That is, I am storing the value, the addition of value in the id index, right? And again doing the same for nums2 also. Then I am returning, see here, in every index I want I comma all values of I, that is id comma value, right? For I in range of 1001, that is the max length if the value is not equal to 0. If the value is not equal to 0, I have to do this, right? So I have to return this. So this is my first approach. Let me submit it. Right, submitted successfully. Now coming to the second approach, the two-pointer approach. This is the two-pointer approach we use in the merging two arrays, or whenever they ask us to find some two arrays, they give two inputs, and it is a type called parallel two-pointer approach, right? So they give us two arrays. Either they can be sorted or not sorted. We want to sort and do some stuff in it, like two pointers, keep one pointer here, keep another pointer here, and if we can process it and gain the output, it is a two-pointer approach, right? It is a parallel pointer approach. See here, I is equal to j is equal to 0, and I have declared a result. Then n1 and n2 as a length of nums1 and nums2. Now while I is less than n1 and j is less than n2, just unpacking the both values, id1 and val1 is equal to nums1 of j, sorry, I, and id2 and val2 is equal to nums2 of j. If id1 is equal to id2, if both are same, I have to append by summing those two values, and I plus is equal to 1 and j plus is equal to 1. Else if id1 is less than id2, then I want to update this id1's that whole id and values, right? And I plus is equal to 1. Else it is in opposite condition. I have to append the nums2 of j, and I want to update j plus 1, right? After this is the important point. While I is less than n1, I want to append the result. That is if take, for example, I take any other examples and explain you this conditions. Take for example here first of all, 1 will be in the result, then 2, there is no 2 will be in the result. Now 3 will be in the result. Now 4 will be in result. After that the loop gets terminated, right? But 5 should be in the result, right? To add this 5 in the result, we want to iterate I to a length of nums1, and if the I is less than the length of the nums1, it represents that there is some leftover elements in nums1, right? So I want to update that. Okay, it is in the first while loop, and in second while loop I am doing the same for the nums2. If this is not true, it is true. If this is not true, this will be true, right? And returning the result. Just rerun the code, you will understand why we are using this 2, right? Fine. So this is the approach for this problem. Let me run this. As you see, it runs successfully. Thank you.